Yo, 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 good morning, good morning. So today we're going to continue with the adventure of implementing this and eventually more of our procedural creatures in Unity using Unity Graph Toolkit and our own runtime graph. If I recall correctly, I think I quit on a pretty bad note. I think we had a little bit of an issue. So let's double check that first. So we have this graph, we save it. No issues there. And then we play. And we don't have any issues. Oh, yeah, okay, now I remember. So we now have a node called Dynamic Mesh to Polygons node. The idea behind this node is the functionality we have previously implemented. So given a dynamic mesh, we calculate polygons based on an angled threshold. So we go through every triangle in the mesh, and if the normal between two triangles are less than this, pretty much, we put them together into a polygon. So if we feed a dynamic mesh to this node, we should get a list of polygons, and then we take a node called random transform from polygons. So given a polygon list, we want a random transform. So I think the idea is that we take a random polygon in the list, and then we, given that polygon, we calculate a random transform on it. And then we use that one to add a creature STNI prefab as a child to our main game object. And it looks like this currently. So we have two issues here. The eye gets spawned here for some reason. We don't really get... I wonder if... Yeah, we just get the default transform. So it never gets added. That's one issue. The other issue is that the polygon calculation doesn't seem to work, which I find to be shocking, because we tested it thoroughly previous to the node implementation. So I hope something else is wrong, but if push comes to shove, we're gonna have to dive into the dynamic mesh to polygon function again. But we will take it as it comes. So what we can see here is that we have a log that says polygon list of size 6. So if we transform this cube to a polygon list, we do get 6 polygons. We can't see exactly what polygons, but I'm gonna guess it's each side. So these two triangles are 1 polygon, these two are 1 polygon, and so on and so on. But if we go to this graph again and we add a little bit of a node called dynamic mesh slicer, which takes a dynamic mesh and slices it given a plane, and then if we just use the positive result of this, so we keep the part of the mesh that is on the same side as the normal of the plane, pretty much. If we take this, clear this, and play again, now on the other hand, we have a sliced, very nice box with a little bit more complicated geometry or topology. But given how these are structured, it shouldn't be that hard to figure out the polygon list. But if we search for this log message, we have a polygon list of size 13. Which absolutely sucks. So I wonder if we can, during runtime, do I have my test class still available here? I wouldn't be too shocked if I removed it. That was a little bit stupid of me. Okay, we're gonna create a proper test class here, I think, because I have no idea, or I have one theory why we're getting a polygon list of size 13 instead of a polygon list of size 6. The eye is still located at prefab position. I don't know which issue I want to handle first. I want to start today with something easy. And I'm guessing that this issue is the easier one. What's weird, however, is that our transform data here tells us that we should have a different position. Yeah, let's see if we can get this one in the correct placement first. I just want to see what happens if we set it at this position. 0.5, 0.02, and 0.04. Oh, that's beautiful. It's a little bit too big, but if we were to scale it, it's still outside. No, it's perfect. And then we have a rotation of, this is a quaternion, I think. Yeah, I'm not even gonna try to translate that to Euler's. But I reckon that it's something like, if I were to guess, maybe something like this. Yes, okay, so the transform data seems to be okay. It's just that we don't apply it to this prefab for some reason. So let's see where we output this transform data. Random transform from polygon. We debug it here. Great. And then we put it into our dictionary here. One thing we can check as well is failed. Failed to generate random transform from polygons. Can't output Unity Engine quaternion, can't output vector 3. Okay, yeah, I get that one. That's okay. So after we have set this one in the cache or return it as a value, then we have a node that is called set transform runtime node. And the fails we are getting in the log file is from here. We try to, I just want to double check this one. Get T. Okay. Beautiful. Yeah. The errors we're getting is from here because we try to do, we try to get input vector 3. We don't have a vector 3 input. Then we try to get a quaternion. We don't have a quaternion input. And then finally, hopefully, we try to get transform data. And if we get transform data, we should be setting position, rotation, and scale. And I think the issue might be that I once again, can I do this? Almost. That I once again forgot to do this, i.e. that we properly serialize these when we save them in a scriptable object. Let's see if my hunch is correct or widely off. Yeah, we're gonna build it again because now we have a few more serialized properties, and then we play it and we get a proper position and rotation. It's still too big. We're gonna fix that later on, but okay, the position and rotation correct. Issue number 1 fixed. So let's move on to issue number 2, which is dynamic mesh to polygons. All it does is dynamic mesh get polygons angle threshold degrees. Pretty complicated. Flood fill. I mean, it's relative. But yeah, my theory why this is wrong, or why we get the wrong result, is not this algorithm itself, but rather the data it works with. Because I did some changes when it comes to triangulate from center. One of these, yes, I fixed this one recently, or tried to fix. But I don't see, so we, instead of using the world right direction, we generate a tangent here. And unfortunately, I don't see. So basically, let me show what this is. When we slice the mesh, we get one side, this one, that doesn't have any geometry. So we need to generate the geometry here. So we pretty much get a list of vertices around this one. They are not sorted. So that's something we need to do. Yo, what's up, Jax? So we get this list of vertices and we need to sort them so we can go in a clockwise order and create these triangles to the center vertex. And I think the normals here might get fucked up. They look okay, don't they? Let's see if we rotate this one. Yeah, we get the correct shading and stuff like that. But basically, so we go through all of these. So we take this one, and this one, create a triangle. This one, and this one, create a triangle, and so on and so on. And I wonder if these newly created triangles, when we try to do the comparison in flood fill, that we are working with incorrect data. So let's check one thing. Polygon list of size 13. Let's see. 1, 2, 3, 4, 5. Shouldn't have to count that. 6, 7, 8, 9, 10, 11, 12, 13. Could it be that our polygons, or this are all the original sides gets grouped as one polygon, but this one here we do each triangle as a separate polygon. If this is the case, why is it the case? Dynamic mesh get polygons. We do dot with triangle normal and n triangle normal. This one pretty much decides everything, right? So something is up with the normals, I would say. When, let's see here. Where do we have bisect, slice here? So when we slice it, we get some slice vertices here, and we get positive and negatives, and then we add triangles, and we generate the triangles, triangulate from center, and we send in a plane normal. We assume that this plane normal is... Oh... One sec. Could it... Maybe. We will... Okay, this theory number one. The plane normal is not serialized, and we do it with the wrong plane normal. But that, I don't know, maybe. Let's see if we have something wrong here. So the first thing we do here is we override the normal. So we create new vertices with the overridden normal, and then we triangulate from center. This one, we sort them using the normal here. I think they get sorted the correct way. And then we triangulate from 0, and we wrap around, yes. Okay. And then we return triangles. Triangles add... Then we return the triangles, and what do we do with the triangles? We add them to positive and negatives. We add triangles, and add vertices is set to true. And I think, like, I don't see anything wrong with that. We're gonna have some duplicated vertices here, but we need duplicated vertices here. Since they have widely different normals. So this vertex here actually exists 3 times. It's 3 different vertices. One with normal up, one with normal left, and one with normal forward. But okay, I'm a little bit worried about, let's see here, dynamic mesh 2. I hope this is true. Or this is the case, but I'm a little bit skeptical. Converters, alters, dynamic mesh, slicer. This is the editor node. I don't care about that one. I care about the runtime node. And we have a slice plane here, which is serialized. That's good. These are public, should be serialized. Okay, let me check. We can probably add something to the log to make it a little bit more, or show some more information to us. But Okay. I'm wondering if we're actually adding way too many vertices here. Don't know how... Yeah, that's it. Holy shit, that's it. Okay, so for each triangle here, when we add them to the dynamic mesh, we actually add all the vertices over and over and over again. So when we add this triangle, we add this vertex, and this vertex. Then when we add this triangle, we add this vertex, and this vertex again, even though this vertex is already added and this one as well. So we should just reuse them, right? So when we try to do the flood fill and we check which triangles share edges, none of these triangles share edges because they don't share vertices. And that's it. So how can we solve this in a nice way? Like the straightforward answer is to just check if this vertex already exists in our list, use that vertex, right? I want to avoid that because I think we store them in a list currently, so we're gonna have to search the list every time we add a new vertex. Option number 2 would be to add the triangles and the vertices separately, and I actually think that's the best answer. And I think I can't really think of a better option, so we might as well go ahead for now and do it. So I would say that the best place to do this is right about here. So we could do positive add vertices, and it's probably not the best way to do it here. We probably want to do it here and here. Okay, not here then, because everything we do here is just override a vertex. Maybe we should rename this method, actually. But I don't want to do that now. Redefine function as a thing similar. So let's see, triangle it from center, triangle it from 0. Okay. It is actually add triangles, okay. Maybe we can do add triangles, add vertices, okay. So maybe the better option is to do add vertices. I'm thinking of doing public void add triangles and vertices. Add triangle, add vertices. So here we do for each triangle in triangles, add triangle, and add vertices false. So that's the triangles. Then we're going to add it like this in the correct way. We don't do this because I want to add the vertices. Yeah, add vertices. It's a bit too much to have this one, isn't it? So maybe we should just do dynamic mesh slice, fill slice hole, positive, negative. The problem is, I thought I was pretty smart when I created this method. But what we do here is that we generate the center vertex like this. So, like, slice vertices doesn't really contain a center vertex, unfortunately. Because what I'm getting at is we could get this result and then get the vertices, but we already have the vertices in a nice list here, except for the center vertex. Okay, we're gonna do this now. I think we're gonna define a set vertex normals. Maybe. And then we're gonna call this one here. Then we're gonna call a calculate. Or first we're gonna prepend a center vertex to these lists. Or actually, this is what we're gonna do. We are gonna make this into a separate method in vertex. So given a list of vertices, we sort them based on a normal in clockwise order. So we're gonna do that. I'm just thinking of ways to optimize this. So I think we're gonna, let's put it into some comments here, so I don't lose my train of thought more than I already have. So first, I wanna sort vertices in clockwise order. So we can either do it sort this list and then this list, but it's the same list, so maybe we can just flip it. Sort vertices in clockwise order, prepend center, or let's do it like this, create and prepend center vertex, and then triangulate, what do we call it? Triangulate from 0. Triangulate from 0. And we need to do these for both. And then we want to do add vertices, add triangles. And all of this we need to do for both the positive and negative, although we can share some of these. I think, for instance, we need to do one more thing. Override or set vertex normals. So we take slice vertices, we set vertex normals here. We're gonna have two lists. Fuck. Yeah, we're gonna have two lists here. Yeah, we're already doing it twice, so yeah, maybe we just do all of these for this, for positive and then for negative. So let's see, does this make sense? We reset all of the vertex normals. We want it to be equal to the plane, or to the plane normal, or the negative plane normal. Then we sort the vertices in clockwise order. Then we create and prepend a center vertex to this list. Then we call triangulate from 0. And the result there is going to be a set of triangles. And then we take the list we got from here, add it to positive, and then we take the triangles and add it to the negative. I think this is what we want to do. So let's take this method. One sec. First, I just want to double check. Where do we call this one? Yep. Good. Take this one. And I think we want to have it in vertex as a static method. And then we can have vertex is a struct. We might as well, can we just set the normal, honestly? But then again, we don't want to alter this. Yeah, we can do it like this. Or maybe even public static vertex. Override yeah, we definitely want to send in a vertex as well. Index, we're gonna bin this soon, I think, or in the future. And triangulate from center, we want a list of vertices, but we want a new normal. Okay. And then we just return this one, and we change this one to vertex. Yo, what's up, Swida? Happy coding to you too. Set vertex normals. Looks good. So then we have this method. Then sort vertices in clockwise order. And that's also going to be a static method here. Vertex sort vertices blockwise. We're gonna have to change it a tiny bit. Sorted vertices is equal to vertices, and then we sort, and we don't have a center vertex position. True. Maybe. Maybe we can just merge the prepend and this one. That's weird. Or we do... Maybe we do it like this. So we change this to center, and then we have the normal. And normal. And then return sorted vertices. Okay. Create average vertex we already have. That's great. So it would look something like this then. Average vertex. I think we can do it like this. Vertex center is equal to create average vertex slice vertices. And then we want to sort them. And when we sort them, we create a new list, don't we? Yes. So let's add one extra space here. List vertex positive vertices vertex dot sort. You know what? We want to override the normals first. When we override the normals, set vertex normals. Yes, we create a new list. Okay, great. So yeah, positive vertices dot set vertex normals. So I'm gonna guess that here we want plain dot normal. But do I want to add this one? Before we set the vertex normals? Probably yes. Okay, that sucks. Or let's see here. Let's double check. Link prepend. Okay. This one alters the list, right? Maybe we want to do this one. But if we do that one, so I'm wondering if we can do slice vertices dot prepend center to list and then new normal. Maybe not the most optimized solution. But it's very important that we change the normal of center as well. Okay, so then this one we're done with, this one we're done, no, this one we're not done with, but this one we're done with. So this one and this one, and we want to sort them. So positive vertices is equal to vertex dot the problem here is that we have already prepended this one and we're fucked. Decisions. Oh, you know what? Fuck it. Do I want to create two different centers here? I guess we can do... Okay. Let's do... The first thing we do is vertex positive center. Yeah, that would work. Center. So we do this, copy vertex with new normal. And then we do positive vertices. Slice vertices. Then positive vertices is equal to... I mean, we could make this enumerable eventually. But sort vertices clockwise, positive vertices, positive center dot position, positive center dot normal. Maybe. This one done, this one done. And then we want to prepend it right before we triangulate from 0. So maybe positive vertices dot insert. Let me just double check this one. Where do we have the insert here? Here, insert 2. Brake lever. Okay. We don't replace, we insert. Makes sense. Insert 0. Positive center. So then we're done with these 4. And then we want to triangulate from 0. So list triangle positive triangles. Triangle dot triangulate from 0. Triangulate from center. Yeah, only used there. So I think we are gonna triangulate from 0 prepend to list. Yeah, what's up, Gavins? What creatures? Just various creatures, you know. We only have 1 currently, and it looks more like a stone than a creature, to be fair. But we're getting there, hopefully. And then triangulate from 0, wrap around true. So triangulate from 0, positive vertices, true. And that should be it. Now we have this one, and then finally we can do positive dot add vertices, positive vertices, triangles, positive triangles, and add vertices false. And we need to do exactly this, but for our negative as well. And then I think we will get the correct result, but we're gonna have to find out. Positive center. Okay, if we do it like this, we will hopefully get correct polygons. So let's try it. Do we have any compiler errors? Can we compile? There we go. Okay, beautiful. Let's see if we can take this graph and save it. Or export it. Yeah, no errors there. And then we run. And what do we have? Polygon list of size 13. Same issue. And that was a failure. The slicing works, however. I want to change this one to negative center as well. Oh, we have a lot of... Okay. I get it. Yeah, we're not done here. We are definitely not done here. Negative. Let's see here. Positive center, positive vertices, positive triangle, positive, positive. Now we have the correct. I don't think we need to re-export the graph. Polygon list of size 13. Was I a little bit too quick to assume that this was the issue? I'm pretty sure this is the issue. It's weird why this one wouldn't solve it, however. Get edges should be the same. Or still seems like the triangles are not, that they are not sharing edges. But we do still get you still get the correct normal, I assume. Yeah, we do. Get edges. It has to be, it has to be, it has to be. Add. Yo, what's up, Mr. Quallam? It has to be this. Contains key edge. Mr. Quallam, I don't know why I'm here. Well, you're welcome anyway. Yeah, it has to be this one. Let's just do... Yo, what's up, Antonino? What's up, what's up? Column, what is this? It's a little bit of a game dev stream. Just streaming when I'm working on my game, you know. Positive vertices for each positive dot. Now let's do for each vertex let's log vertex position, vertex normal, and yeah, fuck it. Let's do vertex UV as well. Let's see what kind of output we get from this. What I don't want to see is, I don't want to see a lot of duplicated vertices, you know. It might be difficult to find the duplicated ones, but we can try. Here we go. Positive vertices, and yeah, they are being added last. So let's take this output. And we get 2. Yeah, we get 2. So what I would like to find here is actually the center vertex. That would be beautiful. Do we have one at 0, 0, 0? Yo, what's up, Kevin? Yo, what's up, Cynic? If we could find, like, if we, here we have the center one. Let's take a look at this one. This one actually only added once. Interesting. So the center vertex, this one, is only added once. We have all the new vertices are these ones. How does it look? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And I guess this is 16 then. Yeah, around 16, 17, I don't know. Yeah, I counted the center one, so yeah, it's 16. Okay, that's weird. So, these gets added twice. These get added twice, but not center. So when we call so that means the center point doesn't get added twice. So somewhere before this, line, we actually add slice vertices. That's weird. Could it be Hmm. Let's take a look at this one. Positive vertices, negative vertices, new vertices. Yeah. Ooh. Ooh. Hmm. Hmm. Yeah, but this is correct. Antonino, yesterday I told some of my coworkers that I'd like to start an indie game development studio. Yesterday they seemed supportive, but today they seem to be using it too much as a joke. It's my dream and I felt like I was treated badly. That sucks, man. I mean, it's hard to tell with the limited information I don't know about the jargon you had previously. I would just ignore them, honestly. But it sucks. Cynic says bad coworkers, fuck them. Yeah. The thing is that, okay, so if we slice a triangle, we put the new vertices both in the negative and positive and new vertices. And then we triangulate from 0. Interesting. Triangulate from 0. But I think that's good. Although I am a little... A triangulate from 0 here should be okay. But positive, negative, yes. Could it be that we add... But this one should only result in... We slice a triangle. This one should only be one triangle. Or actually, no. Or could it be... No, it's actually going to result in more than one triangle. Okay. Antonino, I think I will just ignore it and move on. Yeah, I think that's the best option. Some grown-ups are just like envious of people that still has dreams, you know? It's a sad reality. I'm actually wondering if this screws me as well. Because here we get shared vertices as well that are added more than once. So that means... But if we slice a triangle... Yeah, we can get 2 triangles, yes. Yeah, I think this is a culprit as well. Or actually, one sec, we have the data here. Antonino, at the end of the day, I have one thing more than them. I'm much younger. I still have time to completely change my life from one moment to the next. Yeah, that's true. Pull the youngster card. Worst case scenario. No. What worries me is, we can check here actually. How many? Here we have it. So this one has a normal up. Like we should have the number of vertices we should have here is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we have 1, 2, 3, 4, 5. 6, 7, 8, 9. Okay, so that is an issue as well. But that means that one of these should be... Do I see any duplicated here? Yeah, this one is duplicated, right? Yep. Okay, so we actually have duplicated vertices here as well. That's pretty bad. Ooh. 3 times, so that's this vertex. That's very bad. Although I'm wondering why we got 13 polygons previously, 13 polygons this time, if this wasn't the issue. Huh. So I guess then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, this is still 1. Okay, yeah. Polygon. Okay, we're gonna try this as well. So we have a couple of triangles here. Triangulate from 0. Dynamic mesh. We slice it. We just do add triangles. That's not really what we want to do. These are so small, I think. So we could probably do... we're going to make a quick solution here and just see if it works. So we're going to add a false to add vertices. Can I do... Okay. Now we do positive, add vertex, slice result dot is it flat map or select many? Slice result dot positive dot select many. So we get triangle here, and we want to do triangle dot get vertices dot unique what is that one called in? Nothing ever seems to be named the way I want it in Link. Distinct, right? And hopefully to list. What do we get here? Add vertices. There we go. And then we do the same thing with negative. This slice method went from a few lines to a lot of lines. Hopefully with the correct result this time around. Polygon list of size 13. Get the fuck out. We're gonna have to do some extra logging here, I reckon. Oh, don't we have our list? Yeah, we have our list this time around. Where do we have it? Here we have it. And it's still incredibly long. But I don't see... We still have the same topology. Here we have the normals with how many? We have a lot of vertices with normal up. One, two, three, four, five, six, seven, eight, 9. Should only be 5. It's this one we have duplicated again. Yeah, we do add triangle and Yeah, here we also add the vertex again. But you know what? Maybe, just maybe, I've been attacking this problem the wrong way. Because when I think about it, edges compare vertices. Oh, okay. Yeah, I've definitely been attacking this the wrong way. Because when we add a triangle, we get the edges of the triangle. Check edge. Yeah, it doesn't matter if it's not the exact same vertex. They should still be the same when we compare them. Huh. Damn. Okay, so if that's not the problem, what is? Okay, let's start debugging a few things. What I want to know is, we're going to go to polygons here, get polygons. Bug.log get polygons, unique edges. Unique edges 57. Yeah, that's definitely way more than I would anticipated. That is pretty much every edge, isn't it? Four times 6, 24. Yeah, but then we have this as well. Yeah, it's every damn edge. Then I'm still pretty shocked that it only results in 13 polygons. I guess some of these are shared. Huh. Equals, for when we compare edges, we check if v1 is equal to v1 and v2 is equal to v2, or v1 is equal to v2 and v2 is equal to v1. So we don't care the direction of the edge, we just care about the vertices of the edge. Oh, could it be? This one isn't order dependent, is it? Logical exclusive, it shouldn't be. Or? I don't think this is the... The hash code combine position truncate. When we change the normals, we recreate the vertex, so we should recalculate the hash code. Approximately... should be okay. Let's just do a quick test. 57. Seven. Although UV, UV, UV. What the hell do we do with the UV? We rely a lot of lerp vertex. We lerp UV like this. It should be okay. I'm gonna double check it real quick. So we're gonna do this. Still 57, so it's not that. Okay. We know that the polygons work for a non-sliced mesh. So it's the slicing that fails. I want to see if it's, let's see, 5713. Let's see what happens if we don't fill the caps. Then we get 33 and polygon list of size 5. This is beautiful though. Polygons 5. So yeah, unique edges 33. I don't really buy that. But the number of polygons is actually correct. It's a bit weird, isn't it? How do we manage to join them if they don't share an edge? Oh, could it? Welcome to Twitch, Jax. Yo, what's up, Spires? Thank you for the raid, as always. Appreciate it. You too, you too. I wonder if we're working with a... That shouldn't be the case, but I'm wondering if we have a little bit of a mismatch in the equals method and the hash code comparison methods. 33 unique edges is definitely too much to just get 5 polygons. This data doesn't make much sense to me. When we flood fill this mesh, if this triangle and this triangle don't share this edge, but you know what? You know what? I'm gonna have to do some boring counting here. I really want to know. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. Oh, did I fuck it up already? 33 edges though, that's a bit too much, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, that actually, okay. Yeah, we have a lot of unique edges, that's true. Okay, this is a good result. So nothing wrong here. So now we know 100% that the error comes from the slice method. When we create these new vertices, they don't get the same edges. And I wonder, it's not because of UV. We tried that one. So what could be the cause? Something with these vertices. So the edge comparison logic is 100% dependent on the vertex comparison logic. And it should work both ways. So independent of direction. So something happens with the vertices. So the same vertex don't share position, normal, U, or UV. But then again, combine. Does truncate fuck it up? Nah. Does truncate fuck it up? You know what? We're gonna do it like this. Didn't I have something here previously? Here. Positive vertices. Okay, here we go. Let's see. I want to focus on the ones with, let's see here. Here. What is the normal? It's this one, I reckon. Yes. Here we have a vertex with same normal but not same UV. Interesting. Same position, same normal. The UV is fucked. Let's get this one out of the way. Okay, maybe that's not as interesting. Here we have the same vertex with the same hash code. Actually, I am a little bit interested in this one. Minus 0.5. So it's someone on this. Minus 0.5. Is it this one? Same vertices. Actually, we try to not add the same vertices, so I'm a little bit shocked that we have the same here. Okay, let's narrow it down a bit. Okay, our slice vertices are actually, yeah, we haven't changed the normals yet. Slice vertices are duplicated already at this point. What? Slice vertices. Yeah, we add a lot of... Yeah, that's true. Is that the case? Do we want to... Yeah. So when we slice a triangle, we add so many duplicated vertices. I guess we do. Yeah, we do. Although I wonder if it's enough to just do unique on vertices here. Or could it be that we get the... Oh... When we create a vertex interpolated here, is intersecting plane T, 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 T. And then create vertex. I wonder, lerp vertex. Could it be that we lerp it once with T and once with 1 minus T? That would really suck. Okay, I want to see what happens if we do slice vertices and then we do slice vertices. If we do this little test, polygon list of size 13, it doesn't change the polygon list count. 12 is correct. 2 triangles per side. Yeah, it probably doesn't change the distinct because we have vertices with flipped UVs. I reckon that is it. But then again, if we didn't include the UVs, did I miss removing it from somewhere? If we just remove this UV here, we still have the same issue, right? Because we rely on approximately with UV. Okay. I really, really want to blame the UVs here. So UV gone. UV gone. Polygon list of size 6. Okay. It's the UVs. Great to know. Makes me wonder. So when we slice this one, one sec, it's only the UVs. Yeah, it's the UVs for these. So when we slice this one, We calculate this vertex 3 times. Once for this, once for this, once for this. So why don't we get the same UVs? Because one time we lerp between this one and this one. But what the fuck, isn't that the only time? So when we slice it here, this triangle gets sliced, this triangle gets sliced. This one we triangulate like this, 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 and this one we triangulate like this, 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 and this, this, this. This one gets its UV by interpolating between these two. This one by interpolating between these two. I think it's the T issue. I'm just trying to make sense of it. If we take a look at the UVs here, here we get the same UVs. That's great. Same here. Come on. 0.5. Yeah, that's the center one. Okay, that was a... Maybe this one. Same UVs though. Whoa, whoa, whoa. Yeah, we don't care about slice vertices, we care about... Do we care about slice? Yeah, we do. Wonder if the problem is... Oh, okay. Okay. Could it be? Let's play this again and take a look. I think the problem with... We don't want to take UVs into account with this. Although, or yeah, I guess we need to if we want UVs to work eventually. But it all depends on... Yeah, the slice vertices... Yeah. When we create this one for this triangle, the UVs are gonna depend on this one and the one that was located here. But then when we calculate this vertex for this triangle, it's gonna depend on... what is it? This UV and this UV, I guess. This cube has UVs that are... we have, for each side of the box, we have 0, 0 in the down left corner and 1, 1 in the top right. And when we create these new vertices, it gets screwed up. So this begs the question of how do we actually want to generate the UVs when we slice something, and that's going to depend on what we want to use the UVs for. Eventually we probably want some proper texturing. That's a hard problem to solve with UVs though. But how can we solve it for this specific use case? For this specific use case, we want this one to have yeah, we basically want all of these to have... that doesn't make much sense. But easiest solution would be to 0, 0 down here and 1, 1 here. But if we slice it in a different angle, it's another question. What we need to make sure, however, is that this vertex for this triangle and this vertex for this triangle get the same UV. That's like prior 1. And how can we make sure of that with our current implementation? So first of all, let's start with jumping back to the vertex and re-adding here, because I think we want this when we compare vertices. In what way, independent of what way we approach this. We could do, actually, we could generate UVs for this slice by doing basing it on the plane. Yeah, I think that's the correct way to do it. So the plane is, yeah, we want to define it in the space of the plane, but we still need to get the maximum and minimum point. What we could do, this is one approach. We take all of the new vertices here, project them onto the plane, get min and max x and y in plane space, then we have the max and min coordinates, and then we just normalize all of the positions based on that. So make them between 0 and 1. That's one approach. Probably the best one, actually. Because then it would be independent of plane transform as well. But it's probably gonna be a pain to implement. But I do so want to use this later on, because I've had this idea of adding like moss to the stone creatures, and I want to do it, yeah, based on topology. And having normal or UV coordinates like this would help quite a lot. Maybe. When we slice something, we get a t parameter we might be able to use to simplify it. Yo, what's up, Scafer? Sorry to hear. It sucks being that sick. Hopefully it's better now. Do we have any other solutions? I mean, we get all of these vertices. So maybe... Paper, have you finished the node editor? No, unfortunately not. We're on a little bit of a side mission today, unfortunately. Wasn't planned. We just fell down this hole. And the hole being UV generation during mesh slicing. Good luck with that, yeah. It's gonna be a little bit of a pain. You know what? Can we use local position in a smart way? Maybe. Okay, yeah. Yeah, we don't need to project it to on the plane. We know... Let's see here. We pretty much need to... Nah, I think we can do it with bilinear interpolation. So if we have the object space position of all the newly generated vertices, then we just do, we get the min, max points. So this one and this one, maybe. And then we just interpolate this one. But yeah, it's in X, Y, Z. Yeah, what is it? Inverse bilinear interpolation, maybe. Fuck, can we do that? So calculate this point and this point, give them the UVs 0, 0 and 1, 1. And then we calculate, and then we take this point, for instance, and check where it is. Same height as this one, so should have the same. We have anything? Mm. But okay, if we get this point, this point, this point, and this point, 0, 0, 0, 1, 1, 1, 0, 1, 0. And then we have this point, for instance, we lerp between, yeah, it doesn't really matter how we do it. We can lerp between these two. We do inverse lerp here. So we get this one, and then we do inverse lerp here. And then we should have it. I guess that's it. Okay, let's do a quick implementation of it and see how it looks and works. Dynamic mesh, slice vertices, we're gonna distinct them. And yeah, let's do it a real rough sketch here. Are we gonna need to keep track of all of them? I guess so. We need vertex with biggest y, vertex with biggest x, vertex with biggest smallest x, vertex with smallest y. Okay, let's do it rough. Yeah, we could have just gotten these from this one. Yeah, maybe. Yeah, that's probably a better thing to do. You know what? Let's do it like this. First, yeah, 1 sec. We need to figure out if it's XY, XZ, YZ. Makes it a bit more complicated. And that's why we would like to project it, I guess. Hmm. Or can we... I have this feeling that we can use the normal in some way. Currently, I'm actually thinking about making this a future me problem. I'm gonna have to decide what exactly I want to do with the UVs as well. And I can do some research as well. That might actually be just the way to go today. But that means that we also need to override the vertices. You know, fuck it, I don't have the capacity for this type of problem today. So, where do we get our slice vertices? We get them from here. And new vertex, intersection vertex, we create vertex. Lerp vertex. Lerp vertex. Bool lerp uv is equal to true by default. Otherwise, this. So then we just do, where did we have it? Triangle create vertex. You know what? It doesn't belong here. It belongs here. And then we just do false here. So in our dynamic mesh, when we slice a triangle, but then again, did I fuck up again? Because here we add it to positive, and here we want it to have the proper UV calculation. Okay, maybe the better answer is to do this. We should always lerp we do this, and then copy vertex with new normal, public static vertex, copy vertex with new UV. So we do it like this, and then in dynamic mesh, now triangle, we do this, create vertex, something like that. So slice vertices here should have 0, 0 as UVs, and hopefully the rest will work itself out. Polygon list of size 6, beautiful. With the minor downside that this side doesn't have any valid UVs, pretty much. Yeah, let me just open up my document. I need to... okay, I guess that's one way to fix it. We just offload it into the future. So if we generate it now, everything should work. Polygon list of 6, yeah, and this one, we get a proper position for it. We haven't checked if it fits just yet, but I guess that's okay. Yeah, we're gonna have to add some nodes to that. Okay, moving on finally. So now we have this node network that works. I guess the error lies with this one. But that's good. We have this one. I guess we want to get a random scale. Actually, I think we do have the current nodes to implement the rest here. Let's see. So we set position and rotation here. Then we want to set the scale as well. So I think we can do it like this currently. Set transform editor node. What did we want to have first? Random scale. Vector 3, and we set it as scale. It's this game object, and then we want to have a random vector 3, random. And then we can check what the limits was for our random scale when we had it like this. Here, modules, position. Here we have scale module. Min, we vary it like this. Okay, I think that's okay. So lower bound value 0.05, 0.05, 0.1. Oh, actually 0.025. It's not as visual. Can we resize it? No, we can't. Okay. 0.2, 0.2, 0.1. Keep ratio as well. That's something we want to implement in random editor node. Let's do it now. Random editor node. Add option. And here we have the keep ratio, and we should be getting a bool out of that one. So when we generate the runtime node, we want to do bool. Fuck, did I forget to? Yeah, I did. Bool true. Bool keep ratio. So in our random runtime node, runtime, we want to have a so then when we generate output, generator generate, we would probably want to have it here. Okay, let's do it like this. Bool. Don't we need to serialize this as well? Maybe we don't. Private bool keep ratio. Wonder how we're gonna do it in the transform, but yeah. So let's jump to the end. We want to jump to here, bool keep ratio. Then we want to jump to the end. Shouldn't it be like this? Actually, base. We actually create a generator here. Any compiler errors? 1. Okay, so now we have it. It's a transform runtime node. I wonder if we can solve this in a cool way by doing float generator keep ratio is, it's going to be unused, but vector 2, here we need it. So yeah, we're going to have to do it like this. If keep protected, if keep ratio, and we do something else, we do something else, and this is the else. Here instead, I think we're going to do float t is equal to random dot range, random dot value, and then we return mathf.lerp. Right, this makes sense. Oops. Scafer, you know that feeling when you want to share something but you don't want to go through all the struggle of arranging a repository, doc, CI for releases and all that stuff. Yeah, I know it. I'm a little bit less these days, but definitely previously. I think the hardest part for me was always picking the license. Fucking hate picking licenses. Okay, so this is how we do it here. For vector 3, it's pretty much going to be the same, but with one extra variable. Fuck, should have gotten this one as well. For transform, however, I have no idea. What do we do here? Actually, yeah, it's gonna be roughly the same. Okay. But then, yeah, keep ratio. Yeah, okay, maybe something like this. If keep ratio. Something like this, I reckon. So then we have a keep ratio of option here, which should be implemented in the runtime node as well. Let's assume that it is implemented the correct way. So then we have set transform editor node, we have vector3 as input, and we have this one should set scale. So now we have a random scale to this object as well. That is this one. And then we want to have a few set material properties. That's a new type of node. I reckon we can start implementing it today, but probably won't be able to finish. Maybe, we'll see. But when we have that one in place, are we done? I think so. We have one task left. But then we have all of these node functionalities. And the task we have left is probably the hardest one. So I've said it multiple times, and I'm going to say it again. The right side of this graph, we want this to be repeated a random number of times. It would be very easy if we didn't have this input here. If this was just if these two were leaf nodes, then we could just add a repeat node here, which repeats the graph behind it in the X number of times. But now we want to repeat it up to this point. But maybe we can make it so that we have to our repeat node, we have a stop node. So we repeat it up to we get to this node then. And then we stop. Maybe. That's also future me problem. Probably future me tomorrow. Now let's make something a little bit simpler. So we want to do a set material property node. And so the idea is that we will be able to send in multiple different types. It's going to be vector, color, which pretty much is vector, I guess. Let's make it as a color. So vector, color, float, integer, everything we need. Maybe even texture, actually. That would be pretty cool. Okay, so like so many times before, we want to have a editor node. Let's copy one of these. Set transform editor node. This one has an option of vector 3. Maybe we can go with this one. Yeah, let's duplicate set transform editor node and rename it set material property editor node. Input type, yes. Do I want to rename it? We can leave input type and input. Undefined options. We have an option here, but I want to change value type. Int float. And we do texture. Undefined options, we have this here. And then we remove these. We want a game object input. But it should actually, maybe it should be a material. It definitely should be a material. Let's change this one to material. Value type, yes. And I guess this is texture 2D. Add output port game object, it's gonna be material. I'm gonna wait with this one. Okay, where do we have the material? Oh, we instantiate it with the material. Maybe we can solve that. Then we need a get. Yeah, that sucks, but let's see if we have this one. Set material property name. Material in, material out, vector 3, int, float. Ooh, beautiful. I love this graph toolkit and texture 2D. Beautiful. The only problem being the material here, but that's okay. Maybe we can, for now... Yeah, you know what? We can just change material of this one. Set transform... yeah, we can just do it like this. Material instantiator editor node. And maybe we'll wait with this one. I Bridgestein 01 material. So we instantiate this one, and then we input it here. And we're going to alter it quite a bit. And then we want to change it. Okay, beautiful. I want to wait with these. I want them to come much later, because what I want here is set material editor node. But we're going to do a few more things before here. Okay, set material property editor node. For this one to work, we are gonna need a string as well. So property name, internal name. And then we add an option string with the default value. Actually, we're going to use this one here and this one here. It's actually, I probably want property name first. It feels more natural. So we want to set property as texture. Pretty cool, pretty cool. Fucking hell, I wonder if that's it for the editor node. Yeah, set transform, yeah. I wonder if I want to add an option as well. Now we're going to instantiate a new. Yeah, that's true. Sometimes we actually want to decide here for our nodes as well if it should regenerate. Because if we instantiate one of these and then reuse that one all the time, we won't be able to have multiple different looking instances of this material. We're just going to change this one all the time. So yeah, that's probably an option we want. Cached or not. But it sucks that every node is gonna have it. We will get to it eventually. The repeat node will probably decide it, actually. Yeah, the repeat node will probably ignore the cache. Yeah, I wanted to duplicate set transform runtime node. Set material property. Property name. Okay, so now on to the next issue. This is also one of those nodes that will get a lot of different types of input. How to solve this? Okay, okay, is compatible with connection. Then we want a material. So here's the problem. Are we gonna have to do this? But then we're gonna have to name this one U, right? So let's name this one U. I think we can solve it by this. Let's see, let's say that we have it like this. Input count 2, output count 1 is compatible with connection. Input 0 is always going to be the material, correct? Input 1, however, and we do U. That's pretty fucking cool if that works. If type of T is equal to type of U. But what sucks is that when we set it in the material, we're gonna have to cast it, so we might as well skip this and have some sort of internally defined structure which takes a material and set a value. Although this is looks pretty nice. But whatever I decide, it's gonna be tomorrow because I need to run. Did a few things. Most of the stream today was pretty much debugging or trying to find an issue in the slice. Finally found it to be the UVs. Now I have a big decision to make in the future, how to handle the UVs when slicing. But that's another day. So I think I will be able to stream tomorrow. If so, we're gonna try to finish off the Graph Toolkit implementation, but yeah, it's that then repeatable node that's left. But yeah, we'll see. Thank you so much for watching, everybody. Appreciate it, and have a great rest of the day. Peace.